Okay. Hey guys, I'm Hitarth and my colleague Jay. We are here to talk about Uber's Presto journey from 0 to 90% in Velox. So, Velox migration at Uber scale. So, we did this with approximately 4 engineers. We migrated 500K plus vCores. And we are reading 100 petabytes per month, approximately, serving 10 million plus queries per month in Velox clusters. We have been coming to VeloxCon for last 3 years. 2024, we had zero Velox presence. 2025, we were supporting approximately 10,000 different query shapes, running 3 Prestissimo clusters. We migrated around, which accounted for like 20% of our Presto in cloud. Current status, we are at 90% of data read. As you can see, the blue bar, which is approximately 90% of 100 petabytes. And approximately 25 clusters have already migrated to Prestissimo. This kind of accounts for 10 million plus monthly queries. So how we started carefully. We started with something what we call a shadow mode. We were basically running all our queries in our Java clusters. So whatever was running in production, we would take certain queries, run it in our Java clusters, and rather run it in our Velox staging clusters. And if they were passing, we would put it in our eligible fingerprint list, which is like a query shape. And those were the eligible queries which can run in Velox. So we started with that approach. And what we found with that approach was it was um, eh, why we started with that approach was basically we wanted to only run verified queries so that uh, we know that this query shapes are working correctly. They do not have problems of it crashing on the clusters, causing other queries to fail, and yeah. So, but running all these queries on a staging cluster is painful, right? Like you basically running queries twice. It becomes a bottleneck, and after some point of time, we thought that this is not a scalable solution if we want to reach what 100%. So I think that's when we started with the second phase where we flipped eligible fingerprints with ineligible fingerprints. So we now were making all queries go to our Presto Velox clusters. Whatever was crashing, we were putting it in our ineligible fingerprint list, and we were retrying that on Presto Java clusters. So in order to even get started, we had to do a lot of Parquet enhancements. Uber is having all of its data, if not, well, most of its data in Parquet, and there were a lot of issues initially. So I think one thing that helped us a lot was the backward compatibility testing, where we took the Parquet Java unit test, rather Presto Java unit test for Parquet, and made them run, same test, made them run using native Parquet reader. So that actually helped us uncover a lot of issues, and we were able to kind of fix a lot of them, especially related to backward compatibility of Parquet versions. Um, on top of that, we also have something called as CLAC, which is column level access control, which we have at Uber. It's an open source feature in Parquet, but it was not there in Velox Parquet reader. So that is something that we implemented. There were also issues on row group skipping. We also had bunch of our Parquet files which were having humongous Parquet footers. So those queries would kind of take up a lot of memory, cause crashes. So we were able to kind of identify which tables were having such large Parquet footers and were able to eliminate those. Result correctness was a paramount. So as we started cautiously, right? We were using verifier extensively to identify which query shapes we are supporting and which query shapes were causing any result incorrectness issue. We uncovered a lot of issues. I've highlighted 3 issues here. First one is the complex type, where a null handling issue was causing incorrect results in Parquet reader. The second one, when we were migrating our XP workload, which is heavily using CTAS queries, and at scale, Parquet writer was having some incorrect issues, which we were able to fix as well. Then there was also an issue with wrong result due to column skipping, which was again in like Parquet reader. All this I have already kind of committed to open source as well. I'll hand it over to Jay to talk further.
Yeah, so I'm going to talk about a few key learnings that we had through this migration. So first of all, like Hitat said, we were a team of 3 to 4 engineers. We had to be very focused during the migration. Of course, everyone wants to work on complex things like improving efficiency or memory or doing something in joins, but we had to be very focused. So our strategy was simple. We used to adopt everything from open source, and whatever has issues or bugs, missing features, we used to implement it. So the goal was clear in our heads. We had to just migrate as much traffic as we can, as quickly as we can. So for that, we had to be metric driven. So we had clear metrics on what we need to do and how do we need to do. So for that, we had like a unified dashboard, which I just have a screenshot. That dashboard has metrics like system, CPU, memory, file descriptors, also precision metrics, right? Like from open source, basically memory arbitrator, allocator. So one key thing that we learned was that most of the metrics in Presto were already there in open source. We just had to make sure we understood what they represent and add our own where we needed. So that was our focus, having metrics, using metrics to see what was wrong and fixing them quickly. Yeah, so one of an example of using metrics was when we just found an issue where there were a lot of fragmentation in our workers causing ooms, and the memory was not, the RSS was not stable. So the below graph just shows the RSS before and after. So using the dashboard, ruling out things, for example, first we ruled out maybe memory leaks in different places using metrics, and then we finally made some theories, did some testing, and finally when we just switched the default allocator to Gmalloc, we found out that everything was gone and the RSS was stable. So just an example of the previous slide. Yeah, another key learning was to audit all the configs. So most of the time when you're working with open source, you just accept the default configs. But for fast-moving projects like Velox, for example, it's really important to know what you're pulling. So in this case, just an example that one of the config was lesser than the other one, which led to some queries with some cryptic errors. Like failed to, something like that. So it's same, using metrics, we figured out where, like what was the anonymity, looked at the code, and then we figured it out. But yeah, that was a key learning for us. Yeah, another, just to point out, not like learning, but we found out that the async data cache of Velox was really useful for our use case. So as you can see, for our experimentation, it hits around 80 to 90%. Sure, the workload is questionable if it's hitting that high, but still, as you can see, it's still useful. Even for our interactive workloads, it's around 40 to 45%. So I think it's really important for us. Next slide. Yeah. So a few investments we have done which are in the storage layer. So Uber is migrating to cloud on GCP mostly. So one of the optimizations that we worked on was using the gRPC C++ client. So open source Velox currently uses an HTTP-based client, but when you work on GCP and accessing GCS, you can directly use gRPC-based clients, and as you can see on the green path, you avoid a network hop. So using that, GCP could give us more bandwidth in our own zone. So that was one thing we worked on. Also, we are working with the GCP team closely on like bidirectional read, using the same connection, and maybe even reducing operation costs as well as latency. Latency for maybe AI workloads, if we do invest in that. Also, we are also experimenting with some Elixir as a remote cache. So as you know, in cloud, operation costs are everything. And we're trying to see if we can, better improve our cache and have a better, like a lower bill on operation costs. Yeah, so finally, so before the migration, everyone knew Velox was good. There were TPC-DS benchmark. So then the question is, after the migration, did you really do it? Like, did you solve the goal? And if you can see here, we actually did it. So we just did a final like benchmark to close all the discussions with Java. So first of all, we shadowed production traffic to 2 identical Java clusters. And as you can see, the numbers are already there. It's like 2.4x faster and better success rate, better reliability. Also on the below graph, you can see that the yellow line, the Java cluster was peaking at like 90% utilization, whereas Velox could run even more. So that's what we've been working on. Maybe in future, we can also improve the Velox utilization by squeezing out everything we can and doing more. So yeah, so for closing the final gap, I think the next presentation is already going to talk about it. But yeah, our goal is clear. We want to stop all the retries. So right now, if you saw in slide 1, we still have some data read in spent in retries. So we are going to like stop that. That includes implementing some UDFs, which is left, some long tail and crash issues. Also, I think Kafka and MySQL connector are going to be important for us. So we actually have a lot of queries on Kafka. Users use Presto to quickly debug and see if their Kafka has some issues. So, I mean, Kafka push and pull has some issues. So that's what we're going to be working on. And yeah, that's it. Open for any Q&A.